Hi folks, welcome back to Physics with Captain Rod. I'm making this one here to help you out with numbers 12, 13, and 14 in your Physics 109 Unit 6 homework. So this one, the first two here are about, atomic structure and the masses. So here's some numbers you need, all right? The mass of a proton is 1.67 times 10 to the minus 27th kilograms. And the mass of a neutron is approximately the same. To three significant figures, it does not change. So you can use basically that same value. And the mass of an electron is 9.11 times 10 to the minus 31st kilograms. Now, if lithium is number 3 on the periodic table, and what this means is it has 3 protons. Now you can have what are called isotopes. It's possible for lithium to have 3 protons and 4 neutrons, but for this problem we're going to assume 3 protons and 3 neutrons. So you should be able to write down something like this. The total mass equals, right? You got 3 of these and 3 more of them. So basically 6 times that mass. And one thing to notice is this. A lithium atom, right, if it's not ionized yet, will have 3 electrons as well. But look at how much smaller the electrons are, 10 to the minus 31st. They just don't have any effect. So number 13 is kind of about that. By what percent does the 3 electrons increase the mass? So let me go back to number 12. When you do this, do 6 times, I'm going to put m for the heavy particles. That will take into account the protons, neutrons, and electrons. I'm sorry, the protons and neutrons. Where by m here, I'm talking about this value. And go ahead and add to it 3 electrons. So 3 times, I'll put a little m here. That's the mass I'm talking about, this guy right here, to get your total number. Now, by what percentage does the electrons affect this? Once you get that total number, we're going to take this term, 3 times the mass of an electron, and divide it by that total mass, and then times 100 to get a percentage. So this is the mass of 3 electrons, and this is going to be the total mass that you calculate in number 12 times 100 to make it a percentage. You should get a very, very small number, probably something like 0.001, give or take. Okay, number 14. Let's see, when the lithium atom loses the outer shell electron, how much does the mass change? So if this is a conceptual question. If it loses that electron, I'll put then the change in mass is equal to some number, right? And I'm going to let you think about what that is. You don't have to calculate that. That number's kind of sitting on the page somewhere. Where it says given as a percentage, take that number and again, divide by the total that you found up here, and then multiply by 100 to make it a percent. And then let's see, what is the charge of the atom after losing the electrons? So when the lithium atom has 3 protons, it's got 3 pluses, and 3 electrons, it has 3 minuses. Now remember that a proton has a mass of, a charge of 1.6 times 10 to the minus 19th coulombs. And an electron has a charge of minus 1.6 times 10 to the minus 19th coulombs. So when the atom has 3 protons and 3 electrons, it's electrically neutral. But when it loses an electron, think about what the net charge will be. And hopefully you can write that number down. So hopefully that'll get you through those problems. Have a great day.